Yes, dear friends, here is a figure on the board, and here actually I could have drawn other way also, but I draw this figure to develop an understanding. Here, North Pole, South Pole magnet are there, producing a vertical magnetic field, and in the space, two parallel rails AB conducting AB are there. On this there is a rod PQ moving with speed velocity V from left to right. The magnet produces here a vertical field. Actually I could have drawn like this case, vertical field there, and this rod is there moving in this field on the rail. But just to develop the idea of diagram, the pole, north pole, south pole produce vertical magnetic field. Rails are parallel to this horizontally, and road is there. So you are asked here so many questions. Here you are given that length PQ 15 centimeter, and magnetic field due to this magnet 0.5 ampere, resistance of loop 5 milliampere, जो भी होगा, constant velocity V 12 centimeter per second. 12 centimeter per second. Then you are asked, give the polarity of give the polarity and magnitude of induced EMF here when K is open, suppose. Or closed, whatsoever it may be closed, may be open, key, K. This is ganometer here. So that is simple. Polarity means which end will be at higher potential and which will be at lower potential. The field is vertical. Rod moving this way, electron are going this way, V cross B. V cross the positive charge force will experience from Q to P. Actually remember, different authors have created lot of confusion. Remember F equal to Q into V cross B. I told you while proving laws of electron induction theoretically, when this rod, a conducting rod has free electrons, and when it moves, they experience force. Force on moving charge magnetic Q V cross B. If it is positive, so V velocity of charge this, magnetic this, V cross B, positive charge पर इधर लगेगा, तो electron will go this way, so P will be at higher potential than Q. तो polarity क्या हुई कि P will at positive potential and this is negative, and then modulus BLB. You are given P 0.5 ampere or L 12 centimeter and 1 or 2 meter. Sorry, length कितना था? Length is here 15 centimeter. So 0.15 or into 12 centimeter, 10 to the power minus 2 meter. We multiply it in a volt, will be the EMF. Do it yourself. Now, question is this: if excess charge is built up at the end of rod when K open and when K closed, excess charge built up on the point P and Q. If K is open, so simply you can say in open it is okay. By this Lorentz force, negative electron goes this way, here come get here, and definition of electron created here will give positive charge. So excess charges are built up on the two ends. Plus charge here, minus charge here when K open. But what happens if K is closed? If we close this key K, then what will happen? You may think that current will flow this way, and so no charge left. But you know, electric charge flows due to potential difference, and potential difference will be there if there is excess charge. In both cases, positive charge will be excess charge will be there when whether K open or K closed. But when we close key, then electron start flowing this way and current goes this way. And you can think that the electron have start moving, the more electron will coming, this excess charge will be there. In both cases, whether K open or K closed. Please, this is important question. Now, with K open, जब K open थी तो एक्स इलेक्ट्रॉन थे यहाँ, तो इलेक्ट्रॉन्स डू नॉट एक्स में नेट फोर्स. Q एंड पर एक्सेस इलेक्ट्रॉन होंगे and there is no net force on electron, though electrons are moving magnetic field that F is equal to minus E into B close B होगा. This will be there. But why there is no net force? Actually when K close or open कुछ भी हो, open है, तो there will be net positive charge also. So there will be Coulomb force of attraction between electron and so that force due to magnetic field. Force due to magnetic field. On electrons when rod moves is balanced by electrostatic force of attraction due to positive charge built up on and T. When rod moves, whether K closed or open, by induced EMF will be there. There will be net positive charge, negative charge here this side. So the balance is there. If rod stop moving, what will happen? If the rod stop moving, चलना बंद कर देगी, तो this force will disappear. No excess charge will be there. They will get mixed up. Potential difference will be there only if the rod is in motion, whether this way or this way. If we stop moving, lowering force on electron stop acting, and if there is an excess charge, they attract each other and get mixed up, and no potential difference will be there. Now there are some questions which I could not write here. What is the retarding force on rod when K is closed? When K, we have tried E equal to BLB. So I will be B upon R यानी कि, and this rod of length L is moving. So that retarding force is equal to BIL. Please solve yourself. This question from NCERT book. Question number है ये 6.14. अबे BIL और I this. So it will B square L square B upon R. Put the value, get the answer. In which direction force? Retarding force. If rod is moving this way, this force is this way, opposite. And the agency pulling this rod is acting, doing work against this. You are asked power. Power equal to force into velocity. So it will be square L square B square upon R. Please put the value, get the answer. Have NCERT book with you, please. If you are preparing for any exam, whether board exam or any other exam, how much power dissipated is the same. And what is power when K open? If K is open, then no current will flow, motion of electron stops, and that force balanced by electrical force. So no power dissipated, no power used. It will move freely. What is the induced EMF in the moving coil rod if magnetic field is parallel? Means if the magnet is north pole, south pole, horizontal pole, then no field line will cut and no induced EMF. So this is one question here from NCERT book. Now there is other question. but solve it yourself. I have drawn the diagram just for sake of understanding. Because nowadays students are looking easier and easier. Easy going person will not be successful. We have to work hard in this age. See, our India has achieved and they have gone to moon, and this work started in 62 or 63, and we are able to complete now. That way, every time for new things which you are discussing, you are taught here, you are told the ways, follow the way. There is 6.15 question of NCERT book. Airport solenoid है. Here we have airport solenoid which has length 30 centimeter. Length 30 centimeter. This area is equal to 25 centimeter square. Again, area 25 centimeter square. Number of turns 500. 500. Carries current of 2.5 ampere. The current reduced to 0 in 10 to the power minus 3 seconds. I becomes 0 in 10 to the power minus 3 seconds. How much is the average vacuum induced across the end of open switch if the circuit ignores the variation of magnetic field near the ends? Actually, I tried many times to tell you this phenomenon of self-induction is equal to minus L di over dt. So when you in the night switch off your circuit, in home you switch on or your fan or a bulb, there is a spark in the switch. Whatever the switch is there, when you switch off, a sparking take place. Why? It is because of self-induction. Actually, the switch has two metallic ends, and here we have this connection, and when we switch off, this come out. Only air space there. This part come out. So current becomes 0 in very small time. Due to small time interval, large EM is there. The large potential difference is there. The air gap between these 2 points of switch is very small. Smaller thickness, larger the smaller the resistance. So electric charge starts flowing through air, and when charge flows through air, what happens? The air gets heated, and that hot air produces spark there. Anyway, this was one question. You may be asked why it is there. Now you need L first of all. Di over dt so is there. Di over dt is how much? It is equal to 0 minus 2.5 upon 10 to the power minus 3. We need L. So L is equal to, I told you, mu0 n square A upon L. So put the value here, mu0 4 pi 10 to the power minus 7. And 500 square 25 10 to the power 4. Area 25 centimeter square. 25 into 10 to the power minus 4 upon 30 centimeter. 30 into 10 to the power minus 2. You can solve this easily. How? It is minus 4 cancel. Then it is minus 2 cancel. 4 pi into 25 into 25 upon 30 into 10 to the power minus 5. Or minus 5. तो अगर ये भी हटाएं तो it will be 100. 25 4 का 100. तो 2500 pi upon 3 into 10 to the power minus 4 Henry is the inductance. Put this value here and di over dt. So induced EMF will be minus 2500 upon 3 into 3.14 into 10 to the power minus 4 or into minus 2.5 upon 10 to the power minus 3. this volt will be the EMF. It is nearly 1.05. So 25 minus plus होगा 25 into 1.05 10 to the power minus 2 और plus 3 1 बचा 10 to the power 1 into 2.5. This much volt will be the induced EMF. You please solve it yourself. So there are more questions actually to be done. Please, 2 more questions are there. A very good question is there in our book. But lengthy, I will take next video some more questions for you. But you try the numerical yourself. Dear friend, unless you solve yourself, you have to pen down the problems yourself. Only then you can get confidence of solving the problem. So please do yourself.